Okay, so we're going to start by having a look at one of the writing algorithms questions. It's actually quite easy to pick up a lot of marks on these questions without necessarily getting the right answer. Because these questions are designed to check whether you understand lots of different concepts of programs and programming, such as inputs and outputs and loops and selection and things like that. So, we're going to have a look at this one and see how to get nice easy marks to start with. So the algorithm is required to record a series of whole numbers, it doesn't tell us how many, between 1 and 65535. So it needs to be able to accept the input of them, check if there's a rogue value, which is a value that's not expected, and in this case it tells us that that's a number larger than 65535. It's going to output the total of all the numbers entered, so we need to keep track of the total. We're going to output the mean average, so we definitely need the total for that, and also how many are being entered. We're then going to output the largest number and the smallest number, and there's an example of what's going to be entered or could be entered shown down here. So to start with, to get some easy marks, we need to identify the variables, declare them and set a value for each. So anytime we're inputting into the system, it's going to need to be stored somewhere. Every time we're calculating something or keeping track of something, that's going to need to be stored there as well into a variable. So the first thing is we've got input number. Notice that it needs to all be one word. You also really should put the word declare before that, just to make it clear that you're setting out these variables at the top. So accept the input of each number. We know it's an integer because it's a whole number. We also need to keep track of the total. So we need to make sure that we've got our total here, which is going to be an integer as well because we haven't got any decimal places. We also need to work out the mean average. Now this could end up being a decimal, so therefore we've stored it as a real, or you could store it as a float data type. We need to know how many there are if we're going to work out the average, because the average is going to be the total divided by how many there are. So we've got to keep track of how many numbers we've entered. So that's obviously going to be an integer because we can't enter half a number. We need to know the largest and the smallest, so we need to declare those as well. So again, they're going to be integers because these are whole numbers that we're entering. We also need to initialize these, which means that we need to set them as something. Now, you'll notice that all of them, apart from one, surprisingly maybe to some of you that the smallest is set as a large number, but I'll explain why that is later on. But the rest are just set to 0. Now, to get the mark, you don't actually need to do all of these. If you decide, you know what, I'm not doing the largest and the smallest, I'm not even doing the average, you could just have input number and total, and set input number and set total, and you would still get the mark as long as you don't use something else later on that you haven't declared. So if you use a variable, make sure you declare it, but if you miss some out because you're not using them, that's fine, you'll still get the mark. So that currently takes us up to 1 mark out of 9. Okay, so let's start writing some more parts of these algorithms. I've taken out all the declares at the top just so we've got more room, but imagine that they're still there at the top. So our algorithm is required to record a series of whole numbers. It should accept the number of each, accept the input of each number, and stop accepting them when a rogue value is entered. So to start with, we're going to need to tell them to enter the number. So we need to output a string literal or some text to the screen. So something in speech marks basically. I've put output in capitals. You don't have to, I just think it stands out nicely. It shows the examiner that you understand you need to output something to the screen. We then need to store that somewhere. So that's what our input number variable comes in. Now, we know it's a series of numbers, so therefore we're going to have to put this in a loop. Okay? We don't want to carry on looping forever because we need this rogue value included. So we're going to say loop until the input number is bigger than our rogue value. So this is going to keep going round and round and round until someone puts in 75,000 or something like that. So here you've picked up a mark for the concept of a loop. It doesn't matter, that what's in there isn't 100% correct or it's missing bits, which it obviously is, but you know that you need a loop because you're recording a series of whole numbers and we don't know how many. You've also picked up a mark because you've output some text to the screen, and you've picked up another mark because you've inputted that into a variable. So at the moment that's taken us up to 4 out of 9, which is actually a pass, a grade 4 or 5 answer, which is a really good start considering, if we just flick back, you've only written, you've declared your variables and you've only written 4 lines of algorithm. So not a bad start. So I've just made a bit of space. That's still the same text that was on the previous slide, but I've made a bit of space for the next bit to appear. So we now need to output the total of all the numbers entered. So we need to check first if it's a valid number. So is this number less than our rogue value? Because we haven't ended the loop yet if it is a rogue value. So we need to first check if it's a rogue value. If it isn't, so if they enter 10,000 for example, then the total is now going to become the total plus that number. So if it's the first time through, total will be 0, so it's 0 plus 10,000. If on the next loop they enter 20,000, the total will now become the current total, which was 10,000 plus 20,000, so the total will become 30,000, and so on and so forth. We then need to output that to the screen. So once the loop has ended, because we don't want to output it every time, doesn't do that in the example, so outside the loop, you just output. I've put the word total there. You wouldn't need to necessarily, but it did in the example, so I've output the total. Now, in terms of marks, you've picked up another one because you've got some selection, and the fact that you've also kept track of something, in this case the total, and you've also got another mark for outputting a variable. So that currently takes us up to 7 out of 9, which is a grade 9, based on current or past grade boundaries. So you can see that although our algorithm doesn't work 100% correctly, we've shown a number of different concepts that's going to gain us marks. We've started off by declaring and initializing some variables that we're going to use. We've got the concept of a loop, which ends on a rogue value, because we've looped until we've got our a number bigger than our rogue value. We've outputted a string, something in speech marks. We've inputted into a variable. We've made sure that the name matches up with what we declared at the top. We have some selection, so an if statement. We've kept track of something, so total equals itself plus something else. And we've outputted a variable. Now that's 7 marks. This is out of the mark scheme as a 9 out of 9 answer. So this is where we're starting to keep track of how many to work out averages and max and min. Now there's a hell of a lot more text in there, as you can see. Now many of you, if not all of you, are capable of doing this, but if in the exam you're running out of time, that is a perfectly valid answer and will get you a lot of marks, and it will give you more time to spend on your green foot and your HTML and things like that. But if you do have time, this is what you're aiming for. So if you want to have a look at this full answer, obviously pause the video now, because it's about to end.